Hello students, welcome back to the channel. Today's topic that we are going to see is about the Laplace expansion, which is also one of the method to find the determinant of the matrix. So consider a matrix A belongs to R to the power n cross n. Then for all j is equal to 1 to n, we have two formulas, expansion along the column and expansion along the row. So these two are the kind of formulas that are very important to find the Laplace expansion. So without any further delay, let us see one example of how to use the formulas in order to solve the problems. So let me take one example. Say matrix A is equal to 1 2 3 3 1 2 and 0 0 1. So the first and foremost thing what we are doing is I will apply the Laplace expansion to the first row. You can apply to any row or any column of your choice. So first row is always by a11 a12 a13 and it goes on a21 a22 a23 and it goes on. So first one is that we are applying the formula, that is determinant of A is equal to, what is the determinant? We are writing the two parallel lines with the numbers inside. So that is a determinant is equal to minus 1. What is a11? It is nothing but 1 1. So it is 1 plus 1 into the first element of the first row, that is into 1, and we have to write the minor. How will we write the minor? We have to eliminate the first row and the first column elements, and then we have to write the remaining elements, that is 1 2 0 1. Then again minus 1, so plus 1 plus minus 1 to the power a12, it is what, 1 plus 2. Okay, so into so the second element is 2, and I have to write the minor ignoring the first row and the second column. So it is 3 2 0 1 plus. Why we are writing plus? Because always we are writing the summation. Then we have to write the minus 1 a13, it is what, 1 plus 3 3 into 3 1 0 0, that is the minor. Now let me find out the value. So what is the value? Determinant of A is equal to minus 1. It is 1 plus 1 is what, 2. So it is a positive value, means the value will be positive. So it is 1 into, so what is it is nothing but 1 into 1 minus 0. Now minus 1 to the power 1 plus 2, that is what, odd will be always giving the value negative. So it is always minus 1. Okay, so I am writing it as minus 1 directly. So let me write it as minus 1 into, sorry, minus 2, right? Here we have 2. So it is minus 2 into 3 minus 0 and again plus. Then again we am having the positive value as 4. So I'm writing the values. It's like minus 5. If you solve it, you'll get the answer as minus 5. So the determinant of A is what? Minus 5. Alright, so this is the Laplace expansion. Now there is one more topic called as Sarrus rule. Sarrus rule, in order to find the determinant of the matrix. Sarrus rule, okay, Sarrus rule to find the determinant. So let me take one example. Say 1 minus 2 minus 3 minus 1 3 4 and 2 5 and 0. What does the Sarrus rule say that? So this is one of the topic where you can find the determinant. Okay, and what does the Sarrus rule say is that you can find the determinant by copy and paste the first and the second column to the right hand side. So how will we do that? First let me write the matrix. Now copy the first and the second column to the right hand side of the determinant, that is what, minus 1 2 minus 2 3 5. All right, now since it's a 3 cross 3 matrix, whatever the multiplication you do should contain the 3 elements. So the first diagonal element I will take, it is 1 into 3 into 0 is what, 0, plus now again the 3 elements, next 3 elements, minus 2 4 and 2. So what I will get? I will get as the answer as I will get the answer as what, minus 2 4 and 2 is 4 4s are, okay, minus 16. Then plus again I always need 3 elements since it's a 3 cross 3 matrix. Can I take the next element 1 and 3? No, because there are only 2 values. Now I have to take, so I have to take the elements from the bottom. I have taken the value from the top, I am taking from the bottom. For bottom values we are taking it as minus square bracket 3 into 2 into minus 3. What I will get? It is minus 18. Next value will be 5 into 4 into 1. I will get it as plus 20. Then 0 into minus 1 into minus 2, it will be 0. All right, now I will get the value as, solve it, I'll get -1 -2, I'll get the value as -3. So this is one more way of finding the determinants. Basically, in the question, if they ask you to find determinant using Sarrus and Laplace, you can easily do it. There is one more small topic that is called as trace. So what is a trace? So trace of a square matrix A belongs to R to the power n cross n is defined as trace of A is equal to summation I is equal to 1 to n A I means A11 plus A22 plus A33. Let me take one example. I have a matrix say 4 to 1, 0, 5, 3 and 7, 8 and 6. So trace of the, so suppose this matrix is called as A. I have to multiply all the diagonal, multiply not, I have to add the all diagonal elements. So trace of A is nothing but, it is always denoted like this, it is 4 plus 5 plus 6. So I will get the answer as 15. So this is the trace of A. Okay, addition of or summation of the diagonal elements. Next, we are having several properties under the trace of the matrix. So let us see the trace, the properties of the matrix. So trace of A plus B is equal to trace of A plus trace of B. Okay, this is the first property. Then second property is what? Trace of alpha or any scalar into A is equal to alpha into trace of A. Okay, then let me take one more example. Third example, trace of I, that is the identity matrix, is nothing but, it is nothing but n. Okay, then the last but not the least, the fourth property is trace of A into B is nothing but trace of B into A. Please take examples and try to solve the trace of the matrix. And this is all about the video. Thanks for watching, guys.